Good morning, children. Let us start the next topic of surface chemistry, that is colloids. So, let us discuss. First of all, on the basis of the size of particle, solutions are three types. We can classify the solution in three categories. Number one, true solution. Second is colloids, and third is suspension. What is the difference between all these three? First of all, true solution is a homogeneous mixture. Okay, while colloids and suspension are heterogeneous mixture of two components. Now in this true solution, the size of the particles are below 1 nanometer. That means size of the particles are very small. Its size will be less than 1 nanometer. While in colloids, the size of particles will be in between 1 nanometer to 1000 nanometer. The size of the particles should be greater than 1 nanometer but below than 1000 nanometer. Then it will be coming under the colloidal range. Suspension. In this suspension, colloidal particle should be greater than 1000 nanometer. Okay, this is the difference. Now next stage, colloid true solution is actually true solution is the true solution, while colloids and suspensions are not considered as a true solution. Now here in true solution, the particles cannot be separated with ultrafiltration even or by semi-permeable membrane. While what is ultrafiltration? We will discuss it in this topic only later on. While colloids, particles can be separated by ultrafiltration or semi-permeable membrane, and suspension particles can be separated even by using normal filter paper. True solution is sugar solution, salt solutions, and so many solutions. We discuss it in solution chapter. Colloids are, our blood is colloidal. Ice cream, fat droplets in milk, these are colloidal in nature. Now suspension, soil particles in water, if present, they will form suspension. Soot particles present in smoke, they will also form suspension. They will be not colloids, neither true solution. But in this chapter, we have to discuss colloids. Okay, about the colloids we have to discuss. So let us discuss about the colloids. Now colloids. What is colloids? It is a heterogeneous system in which the size of the particles are in the range of 1 nanometer to 1000 nanometer. Then if the size of the particles will be in between this range only, then we will say that it is a colloids, and it is heterogeneous in system. Colloids contain two components. One is dispersion phase and another is one is dispersion medium and another is dispersion phase. Dispersion medium is similar like the solvent of true solution. Okay, like this is the medium in which the particles are dispersed or dissolved. Okay, known as dispersion medium. It is like a solvent of true solution and it is present in larger amount. While dispersion phase, it is like a solute of true solution. This is the particle which is dissolved in dispersion medium, and it is like a solute of true solution. It is present in lesser amount. Now the next topic is classification of colloids. So first classification we can do it on the basis of physical state of dispersion phase and dispersion medium. On the basis of we know that there are three states of matter generally: liquid, solid and gas. So on the basis of these states of DP and DM, we can get 8 types of colloid, not 9 types of colloids. Why? Because dispersion phase gas and dispersion medium gas is there, so will not get colloids. It will be true solution, because mixture of two or more than two gases are always form homogeneous mixture. They will never be heterogeneous, and that's why it is a not forming colloids. Now the second is when gas is dissolved in liquid, DP is gas and DM is liquid, then we get a colloids which is known as foam. For example, froth, whipped cream, etc. When gas is dispersion phase and solid is dispersion medium, then we'll get a solid salt like pumica stone, foam, rubber, etc. Fourth is, if liquid is dispersion phase, dissolve in dispersion medium gas, then the colloids which we get it is given the name aerosol. For example, fog, mist, clouds, insecticides, spray, these are the examples of aerosol. Now the next stage, when liquid dispersion phase dissolve in liquid, then we get a emulsion. Okay, emulsion means when both DP and DM are liquid. For example, milk, butter, hair cream, these are the examples. Now the next stage, when liquid dispersion phase dissolve in solid, then we get a gel. This colloid is given the name gel. For example, cheese, jellies, etc. Next, when solid dispersion phase dissolve in gas dispersion medium, then we get a colloid which is known as aerosol. For example, smoke, dust, bread, etc. Next is solid dispersion phase dissolve in liquid dispersion medium, then we get a colloid which is known as sol. For example, paint, cell fluids, gold sol, etc. And when both DP and DM, both of them are solid, then we get a colloid which is known as solid sol. For example, many gemstone, other precious stones and alloys are an example of colloids of solid. In this aerosol, emulsion, gel, aerosol, emulsion, here it will be solid, here it will be aerogel. It will be aerogel. So aerosol, emulsion, gel, aerogel, sol. These 5 are very, very important. Now another classification is based on second type of classification is based on the affinity, okay, between the dispersion phase and dispersion medium. Classification based on the affinity of dispersion phase and dispersion medium. On the basis of this, we have two types of colloids. One is known as lyophilic colloids and another is known as lyophobic colloids. What is the difference between these two? As you can see the name lyophilic. Lyo means liquid, philic means loving. So these are liquid loving colloids. That means when the dispersion phase and dispersion medium both have a great affinity with each other, then we get a lyophilic colloids. That means in lyophilic colloids, DP and DM wants to be together because they have a great affinity, and this can be easily formed just by even mixing with each other. And even this colloids, if converted into precipitate, it can be easily reconverted into colloids. Such kind of colloids do not show Tyndall effect. What is this Tyndall effect? We'll discuss it later on, but here in this chapter only, but here just you keep it in mind, lyophilic colloids do not show Tyndall effect. Okay, like for example, glue, gelatin, starch, protein, rubber are the examples of lyophilic colloids. Okay, lyophilic colloids, it can be easily prepared by mixing DP and DM. In this, DP and DM have a great affinity. They are reversible in nature, okay, and they do not show Tyndall effect. While in lyophobic colloids, the colloidal solution in which DP and DM have a very less affinity, or they do not have an affinity with each other, and that's why they don't want to be together. We are just keeping it together by some means or by applying some force, and that's why lyophobic colloids can be prepared only by applying a special technique or a special method, while lyophilic colloids can be easily prepared just by mixing DP and DM and by shaking it. Okay, here lyophobic colloids required some special means for the preparation, okay, and they show Tyndall effect. Lyophobic colloids, they show Tyndall effect. They are irreversible in nature. What it means by irreversible in nature? That means once lyophobic colloids converted into suspension or precipitate, it cannot be reconverted into colloids. That's why it is told that it is irreversible in nature, while lyophilic is reversible in nature. For example, colloids of metal, metal hydroxide colloids, metal sulfide salt, etc. So you can differentiate it first. Here DP and DM. In lyophilic, DP and DM has a great affinity, while lyophobic, DP and DM have least or do not have any affinity. Second, this is reversible in nature. Lyophobic is irreversible in nature. Third, lyophilic can be easily prepared by mixing DP and DM. Lyophobic cannot be prepared by mixing. It needs a special method to prepare it. Next stage, this lyophilic do not show Tyndall effect, while lyophobic colloids show Tyndall effect. Now, classification of classification of colloids based on the molecular size. On the basis of molecular size, we have three types of colloids. One is multimolecular colloids, second is macromolecular colloids, and the third is associate colloids. So, what is multimolecular colloids? Multimolecular colloids means here the particles are very small in size. The size of the particles are, each particle have a size less than 1 nanometer. Many such particles come together, get aggregated, and then they come under the colloidal range. Then it is known as multimolecular colloids. For example, sulfur salt. 8 sulfur atoms when come together get aggregate, then we get a sulfur colloids. Macromolecular colloids, in this, each and every particles of the colloids are big enough to come under the colloidal range. These are called, that's why macromolecular colloids, for example, starch, cellulose, polymers and protein. One thing I want to tell you here, for the formation of multimolecular colloids, any specific concentration is not required. At low, high, at any concentration, particles come together, small particles come together and they get aggregate, and then they come under the colloidal range. Third type of colloids is associate colloids or micelle or surfactant colloids. It is also known as surface acting agent. What it means by this one? In this colloids particle, initially certain substance which behave as an electrolytes at low concentration. What it means by electrolytes? Means those components which dissociate into cations and anions. So, these substances, when concentration is low, they dissociate into cations and anions. When you are increasing the concentration and when they come up to a certain concentration or above certain concentration, then the particle will start get aggregating. Then aggregation of the particle will takes place and then they come under the colloidal range. So, these type of colloids are known as associate colloids, and that particular concentration above which aggregation of the particles takes place is known as CMC, critical micelle concentration. And colloidal associate colloids or micelle formation takes place at a particular temperature, that's known as Kraft temperature. So, these are the certain substances which behave as strong electrolytes at low concentration, but behave as colloids at higher concentration due to association of small particles at higher concentration and form colloids, micelle. For example, soap, detergents, CMC. This is the minimum concentration above which only micelle formation takes place. CMC full form is critical micelle concentration. For soap, critical micelle concentration is 10 to the power 4 to 10 to the power minus 3 mole per liter. ठीक है, for soap के लिए CMC is 10 to the power minus 4 to 10 to the power minus 3 mole per liter. This is the concentration. And Kraft temperature, this is the temperature above which micelle formation takes place. So, these are the two conditions for the formation of micelle, CMC and Kraft. This is the important also for 1 marks question comes ki what is the condition for micelle formation or associate colloid formation, or sometime it comes what is CMC or Kraft temperature. Fine. Now, like you can see here, I am just telling you about that. Soap, as you know, soap is the sodium or potassium salt of higher fatty acid like C17H35COONA. This one, this is known as hydro part, you can represent it like that, and this part you can represent it COO minus and Na. So, when you are dissolving it in water, as you are dissolving it in water, it dissociate into cation and anion. So, at this level they are acting as an electrolyte. When we on increasing concentration increases and reach to CMC, then what happened? This one, like suppose this particle we are representing it like that, and this particle we are representing it like that. This is C17H35 and this is COO minus. So, this particle is known as non-polar particle because this is the hydrocarbon, and this is known as polar part. So, this will get aggregate together around a certain thing. Now, like oil droplets and all, how it is forming, I'll tell you later on. But aggregation will only takes place after reaching a certain concentration. Initially, it will be behaving like a cation and anion, matlab electrolytes, or later on when it will reaches to the CMC, aggregation of the particle will take place. So, this is known as associated colloids or mycelial formation. Now, coming to the mechanism of mycelial formation. Now, you can see here soap is the potassium or sodium salt of long chain fatty acid. It has a polar part carboxylic group which is known as head, and the non-polar hydrocarbon part which is known as tail. In aqueous solution, soap molecules में polar part मतलब carboxylic part pointing towards water, while non-polar parts will be remain on the surface of oil. Where this oil comes, I'll tell you. When the CMC, when the concentration reaches to CMC, these anions goes into the water and get aggregated to form a spherical shape called mycelial formation. These are the soaps. When after certain time they will get aggregate and come under the colloidal range and then form mycelium. Actually, this mycelium formation takes place in soap during the cleansing of clothes. So, let us discuss cleansing action of soap. Now, what is happening? Before understanding the cleansing action of soap, we have to understand how our clothes get dirty. Like suppose this is the clothes. When we are wearing it, oil droplets comes out from our body, and on the oil droplets, dust and dirt particle get stick with it, and clothes become dirty. Here oil is again non-polar part. When we are rubbing the soap, so this is oil non-polar part, and here in soap particle, this is non-polar, tail is non-polar, and head is polar. So as we know that non-polar show affinity towards the non-polar side, so this part, non-polar part will stick towards the oil, and this part will be facing towards the water. So this way all the non-polar part of soap particle will get stick around the oil and they will form mycelium. So here water is outside, water is there, so they will show this is also polar and this is also polar. So polar part is showing affinity towards the water, and non-polar part of the soap is showing affinity towards the oil particle. And in this way mycelium formation takes place. Now when we are rinsing the clothes with water, then this part will be stick towards the water. It will not break its bond because it is a strong dipole-dipole interaction. It will come out with water. Along with this tail particle will also make a bond with the oil particle. So this part will come out with the whole oil droplets and dust particle along with water, and clothes become clean. So clothes are dirty due to organic matter stick to the cloth which is oily in nature. When they dipped in water and a soap is applied, the tail portion of the soap pointing towards dust and aggregate to form the mycelium. Dust get removed, hence clothes get clean. This way clothes, dust and grease get removed due to the formation of mycelium. Thank you. In next class we'll discuss preparation of colloids. Thank you.